welcome into topic 6 DQ1. Let's go ahead and start by typing in our name per usual. Once you've done that, everything becomes alive, right? Now, the first thing we want to notice is number of sides. So this is supposed to represent like an 11-sided die. These tables over here, let's just talk about table 1, is going to be randomly generated numbers 1 through 11. So if you click on this, it says ran between 1 through A4, which is my 11, and it's going to randomly generate numbers all the way for this table. And same thing over here. Same exact function. The only difference between these two tables is for this first one, it's only going to come up with 1,000 numbers that we care about, so 1,000 randomly generated numbers between 1 and 11. And table 2 is going to be 4,000. There is a reason for this. We'll get to it eventually. Now, rather than, right, we could go our black cross, we could drag all the way down, but if we want to drag down 1,000 terms, that's going to be a while of dragging. Same thing over here, even more so with 4,000. So what we can do is we can highlight both. We can go to the right corner. We get the black cross again, but now we're just going to double click. And if you scroll down, you'll notice that there is going to be 4,000 terms now generated for table 1, but when it comes to actually calculating things, it's only going to look at the first 1,000. So it works out in our favor. And for table 2, it will do the full 4,000. So again, highlight, go to the corner, get the black cross, do not drag because that'll take a while, and just double click and it will appear. The only thing we want to do in this part is also verify that table 1 over here does indeed have 1,000 rows. That's how many we would like. The way we're going to do that is equals sum, and we're just going to count up all of our rows. And maybe I should have specified first. And you could throw in the zeros if you want to. Notice that there's 0 for 12 because it only goes up to 11, 0 for 13, and so forth. Enter. We do indeed have 1,000, and I'm going to mention two different things. One, you may have just noticed that all these numbers updated. That is absolutely fine for this. They will continue to update. Do not worry about that. And two, the way you want to read this is that my outcome for 1 was it happened 103 times. My outcome for 2 was that it happened 93 times, 387, and so forth. So that is it for table 1 number of rows. Table 2, we're going to repeat the exact same thing. Right, so I'm going to go down to table 2, and I'm going to add up, again, actually let's type it in now, right? Let's say equals sum, and I want to go grab all my frequencies in table 2. And again, you can add them all up. The zeros aren't going to affect anything. Enter. And we'll scroll up, and good. So we have our 1,000 in table 1, our 4,000 in table 2, and that is it for part 1. I will see you in part 2 where we will go through the theoretical probability first. Let's go ahead and do the theoretical probability for part 2. Now, theoretical probability just means if you were to roll a die, let's talk about a normal die because it's a little bit easier, right? It has 6 sides. What is the probability of getting a 1? You would say that happens 1 out of 6 times. Same thing with 2. Same thing with 3, right? They're all 1 out of 6. That is what's known as the theoretical probability. Doesn't mean that's what actually happens. If I roll that die a bunch of times, then I'm going to exactly get 1 out of 6 times, or 2 1 out of 6 times. But that's what we think theoretically should happen. That's what it means by theoretical probability. So for mine, I have equals 1 divided by, and it's how many sides I have. And I do want to reference this cell. Now, because I'm going to use this over and over again, we need an absolute cell. So I'm going to say $A, $4, enter. And the good news is this happens for every single one of 1 through 11, right? My die only goes up to 11. So I don't want to drag this all the way down. I'm going to just stop at 11. And these are all identical. Again, do not worry about the updating. And the even better news is, not only is it true there, it's also true down here. Just because I roll the die more times doesn't change the theoretical probability. So again, I'm going to say equals 1 divided by, and it was $A, $4. Enter. And again, we go all the way to 11. We don't want to go past that because my die stops at 11. You want to go till whatever you have for your die number. Mine is 11. Just pay attention to yours. We don't want to go too far down. So that is it for theoretical probability. And the next part we will go to empirical probability, and the deviation from expected. We'll kind of do both of those at the same time. All right, I will see you in part 3 now. All right, let's go ahead and do part 3, the empirical probability. All right, so the empirical probability is what actually happens in our experiment, meaning we take how many times our number occurred, in this case, right, it's located in G4, and we want to divide that by the total number of rolls. But we want to use a formula, right? So we're going to use this 1,000, but again, that's our sum. And we want to call that sum of our total over and over again for each one of these. So we're going to use absolute cell. So $A, $7. Enter. Perfect. And again, do not worry if these keep updating. I'm going to say that a few times. Now, if we've done this correctly, we can go to the right-hand corner. We can drag all the way down. That gives us all the empirical probabilities, and you will also notice the deviation from the expected is also calculated. So theoretically, this is what we would expect, but this is actually what happens. And so what it's doing is it's calculating the absolute difference between these two values. So it's taking empirical minus theoretical, and it's coming up with the absolute value. Same thing for all those. So we're going to do the same thing below for 4,000 rolls. So in this case, though, our denominator is located in A10. So we have equals our frequency divided by $A, $10. Enter. And we're going to drag down. Perfect. That is going to do it for empirical probability. And again, we can see the deviation from expected. And what I'm trying to point out here is notice the difference between the 1,000 rules with the deviation is, yes, it is very small, but notice that this number becomes smaller as we do more rolls, meaning we get closer to the theoretical probability the more times we roll this dice, right? So we have smaller deviation from the expected. So we'll pause there, and then I'll see you for the average deviation. Let's go ahead and calculate our average deviation. How do we do that? We know we have a built-in average function. So we're just going to say average. We're going to highlight everything we want. And parentheses, so J4 to J14. Enter. And we're going to do the same thing here. So this is going to be equals average, parenthesis, we highlight what we're interested in. So J23 to J33, and enter. Now again, totally fine that these are updating. There is a reason for that. Now we're going to record them. So whatever we have right now, we are going to record. So we have 0.0076. So equals, oh, I don't need equals, 0.0076. And I have 0.0032. I'm going to write this down, and as soon as I press tab here, it might change. It does. 0.0032. Now, every time I press enter, these are going to re-update, and I'm just going to start typing in these answers repetitively so that we have 5 different averages recorded. So as soon as I go to a different cell, it updates again, and I'm going to now record these two. So 0.088, 0.00, was it 00? 0088. And I'm just going to record this one. I know it's going to change as soon as I go, but 0.0026. Okay, let's record our next two. 0.010. And this one is 0.004. So we got to just do this a couple more times so that way we'll have 5 of these. Again, we want these to keep updating. 0.0084. And this one is 0041. 1,000 rolls is going to be 0.0065, and it is 0.0029. So we just recorded 5 different reps here. And the reason we're doing this is because in a second we're going to interpret the results. But notice, right, the table of deviations for 1,000 versus 4,000. So I'd look at this for a little bit and make a conclusion as to what you notice. What is happening to our deviation from 1,000 to 4,000? So I will see you in part 5 now in a second to interpret. Last and final part here in part 5, the interpretation. How do the average deviations from the table of average deviations, that's what we just filled out, compare between 1,000 and 4,000 rolls? What do you think would happen if you rolled more often? What about less often? So I'm going to leave this for you guys to fill out, but essentially it's what we've been mentioning the whole time. Our deviation gets smaller as we roll more. If we roll less, our deviation gets larger. And so remember what the deviation is so that we know what we're talking about. The deviation is the empirical minus the theoretical. And so the idea here is if I rolled this die over and over and over again, it should be the case, and I performed this experiment, that the theoretical and the empirical probabilities would eventually be so close to almost the same. They won't ever be exactly the same, but they'd be really close. So as you roll this, this time we did 4,000 rolls, but if we did 8,000, right, our average deviation would be less. If we did 16,000, 32,000, I'm just going up by factors of 2. Right? Every time we would have a smaller average deviation. So that is the general idea. Feel free to write that in any way you would want. And then I will see you in the next DQ video.